So this is the parts of screw jacks assembly. So by using this dimension we are going to do a screw jack assembly by using a tool Catia. Let us start. Click on the start, go for mechanical design and select part design. Here we are going to do this part 1 B body, type as a body. Here select any vertical plane and go for sketch. Here you need to do only the off of the profile which is in etching. Selecting profile, click on the profile and start from this origin of etch direction. So you have to start this as making parallel to the taper one and draw in this way. Click on this trim to remove this extension line. Here select a constraint and finish off this constraint part. Dimension given. So here you have 140. I am giving only radius. Here it is 40 and this portion is of 25. So you can see all here the dimensions is in diameter. I am giving radius. So from here to this it is of 35. Place it here like this. So again from this to this depth is of 3 mm and here from this point to this it is 50 and from this point to the axis is again 50. Now you should select from this top base to the bottom base, it is mentioned as 20 and then the rest of thing is entire height of the body is 185. This is 185 and here you need to coincide this base bottom to this horizontal. Select these both and right click, select coincide. Here give the thickness as 10 mm as mentioned in the diagram and then select this point and this axis as this is the 67, radius becomes 33.5. So it is all green indicated, so it is constraint. Check again the dimensions whether it is correct or wrong. Then next step is to exit the workbench. So you can select by direction. Here if you select right click you have a Z axis. You can select this or else you can select here a Y direction. Click OK. Then here it is mentioning that you can see here radius 8. So click on this edge fillet, click this edge and give as 8. OK. So this completes the body part of screw jack assembly and we move for a next diagram. Next part it is nut. So mention here it as nut. Okay. Again select the same plane. Okay, click on front plane. vertical front plane. Go for sketch. Here draw the profile, it is shown here in the hatching one. So select a profile and draw the hatching part of the nut which is mentioned here. As it has to, you have to draw like this. So here click on this, now click on the dimension, it is becomes 19 minus 3.5. so radius is 19, and in the 7 pitch you will get off of that it is 3.5 and it becomes 15.5. now select this outer one, outer diameter of nut, and give dimension as mentioned as 15. Here it is 15, you can enter as 25, and as same as another outer of nut is 45, and the height you need to adjust. So from here to this it is 10, and from this top to this edge again it is 10. So entire the height of the nut is 45 mentioned. You can see it is 45. Here it is 45. So then exit from the sketch, exit from the workbench. Now you need to select a shaft here and then click on OK. Here select edge fillet, click on this edge fillet, select the corners. Here it is shown 1, 2, 3 corners you need to select. So select all the 3 corners, 25 as mentioned radius here, click OK. Now what you need to do is helix. So here you type C and semicolon and enter. So you will get this. So right click on the selection starting point, create a point. Here below you have a edge, you have to select this below nut. Here you should make a position of the point in this direction. So OK, now we have created a point, you can see it is visible here. Here you can see the point. So I'll select an axis, Z axis, which is 7, it is mentioned here, answer as pitch 7. Height is 45 of the nut, I'll give 45. OK, now we need to draw a profile, square rectangle. So select this sketch and draw a centered rectangle like this, then click here, click on the constraint, give as 3.5. this side also it is 3.5. now click on this constraint, here click on this point, this edge of the bottom, click on this edge and this, enter as 90. So you can see this threaded portion is 38.7, it is outer arrow, you can see it. Then 19, so 19 radius for outer line, 33.5, 3.5 this side. From the sketch, here you select this slot. This is so click on this curve, select this curve. Here the profile control should be selected as pulling direction, and the axis is, you can select on this nut, or else you can right click here and select Z axis. You can see, click on preview, you can see how from where the thread is stopped. So here it is stopped somewhere else, here it is stopped at this point. So it has started from here. Okay, then click OK. Now what I do is, I'll select this, double click on this helix, and I'll increase height of that helix as 60 and click OK. And then now you can see top face of the nut. So the thread should be formed like this, and we cross check by in the drafting sheet, so whether we got the same dimension. Now click on the draft, we go for drafting sheet, select a blank sheet, and now we call for nut here to cross check the dimensions here which I mentioned. Okay, right click and show all hidden lines, axis, center line, threaded. Okay, here you can cross check the dimensions to match this. We go for dimension, click on this, and this one you can see it is 7 pitch as mentioned, and we cross check even diameter. So this, from this point to this line, it is 38, so it is matching. So now this end, we move for spindle screw, new sheet, type it as part, here spindle screw. Okay, so as it is here, you should draw, let us go move for spindle screw, that is screw spindle mild steel. So this one we are going to do now. So click on this front plane, go for sketch, then again you have to repeat the same thing. Click on this 0 coordinate origin, draw the profile, and as it is you should draw, and this, so this completes, so you should draw like this. So draw in this way. So this half of section we have drawn. Now I'll select this diameter, this side I'll keep it here like this. Now we show the diameter of this. So it is shown 38 into 7. This is outer again. So we'll give it as radius 19. Height of this is 83. I'll select from this point to the top of this, it is 83. From this point to this, it is of, as mentioned, it is 12. And see this, make it as horizontal, and again right click, vertical, double click here and make it as 10, and even this side also you should make it as 10. So both should be 10. Okay, so this is of 10 and this is also 10, and again repeat the same thing. There is an option You can draw a rectangle here and you can chamfer in the 3D screen. So I am drawing here directly. Now the diameter of this line, it is here it is mentioned 65. So 65 divided by 2. Now this diameter you should show. It is of 12 diameter. We go for 6. And now it is turned to green. So we show entire height of this from here to here. Before that we over constraint, it shows over constraint. So here it is 240, enter 240. Exit from the sketch and select shaft, select an axis. Okay, now we name thing as in the nut. So call helix, HELIX, enter. So create point, right click on this and select. So here you should create a point. I'll create a point here, then OK. So you can see the point is created here. Now pitch, go for axis, Z axis, pitch as 7. So pitch is 7 and the height is of here 240 minus 83. So 240 minus 83, it is 157. Okay, now we go for slot. Before that we need to draw a profile. Select plane, sketch, draw centered rectangle and give dimension as 3.5 for this centered rectangle profile. Here also should give it is square threaded. Constrain it to click on this constraint, select outer line, and to this axis it is 19. From this point to this edge is coincided, then exit, then select slot, select a curve. Here it is in the pulling direction. Show for axis, select axis as Z. Now here we have to show I'll select this merge slot end, so it moves like this. So you can see from here it is moved. So if you select this merge slot to end, here you will get a finishing, then exit. OK, that's it. OK, so you can see it is started from here and it has ended on this. So from this point you got a, then we need a hole on this. So click on the plane, go for sketch again, draw a circle on the vertical origin, and then diameter is mentioned as 12. Go for 12. Be positioned for 35 from this bottom. 35. Exit from the sketch, select this pocket and select a mirror extension. You can drag from here like this, or else you can give dimension here. Now we have a hole here, and it is to be get threaded. Select hole, select this face. Here it is of, I'll select a blind hole. So we have a V finished here. Bottom should be made V type. So instead of flat we go for V bottom, and it is blind hole. The type we go for, okay, it is simple. Then threaded, select thread option. Here select some thick pitch and select this M. It is M12. It is mentioned here M12. So select M12 and depth of the thread is 25. It is mentioned 25 and enter 25. See the preview, and the whole depth is of 25. It is 25. I'll go for 30. Then click on OK. Let us 25 is depth of the thread. I'll give 2 mm extra, that becomes 27, and preview. So okay, so this is the hole with threaded and V bottom. Okay, that's all. So this finished the spindle screw. Here type as cup. Okay, we get a new sheet. Click on vertical plane, go for sketch, click on this profile, draw profile as shown in the diagram. And from this point to this, it is of 45 divided by 2, and this line is of 20 divided by 2. Now from this to this, it is of 12, and the entire length is of 45, 42, and this thickness is of 6. This point to this, from axis to the point, is of 65 divided by 2. So this completes the cup. Escape, exit from the workbench and click on this vertical direction. So here you need a cutouts here. So click vertical plane and go for sketch again. Draw a circle on the origin in the sense a vertical direction origin, and then give a diameter to it of mentioned as 5, then diameter becomes 10. So from this point to this, it is of, we make it as coincide. Exit from the workbench. Here select pocket in this direction. Now we do here so we are doing a circular pattern. It is asking for instance parameter. In this parameter, select complete cron, and instance is 3, and select this reference direction as in this direction, and this object to pattern is this cutout. Here mention instance as 4. Okay, so we'll get this. So that's it. This ends the cup, and now we go for another part. It is screw. Here this is P part. Enter as screw. Now select the same plane, vertical plane, draw profile, then start giving constraint. It is 12, that means 6, and enter height of this screw is of 27, and we'll drag it this for below and give height of 6 mentioned here. Then the entire this diameter is 24, radius becomes 12. Exit from the sketch, go for shaft, select this vertical direction. Okay, so here we have some V bottom. Again we go for edit. Here we do some edit. So from this point, so it is okay, from this point to this, and the distance from this to this, we make it as 3 mm, and we extend from this line to this, and I will trim this, delete this line. Now exit from the sketch, we'll get a V bottom. Now we have a slot here. Draw a rectangle. So using a centered rectangle, give distance from this to this is of some 2 mm, and again and click these 2 lines, make it as thickness not mentioned. Here's okay, it is 2.7, 2.4. Exit from the sketch, select this pocket, mirror extend both sides. So this becomes okay, this completes. Now we move for new one. Here we need to do screw, so we need to do threading. So select this thread. Here we need to select this is for hole, and this is for threading, and this is for tapping. So we are doing threading on external. So select limit face and lateral face. So this is our lateral face. Select this face, and limit face is of this. It should be flat actually, and we select this one. Okay, now height will be of increase it for some height by saying preview. Okay, enough. Click OK, and before that select here. We need to give some parameters still. Here metric thickness I am selecting, and it is taken M12, and then depth is 25. Okay, this thread has been taken. and now we go for new. Here we have a Tommy bar. Go for P, click on this, enter Tommy bar, and then OK. Select vertical plane again, a draw profile as mentioned in the diagram. Start giving constraints. From this line to this we are mentioning a diameter. The diameter of this is 12. I am giving 6 of radius, and from this point to from this line to this it is of 20. Go for 10, and this angle is of 45. So click this line and this, make an angle, click on this and make it as 45. Then what else? Entire length is of, so this length is of 62, and entire length of this Tommy bar is of 275. Okay, and then that's all. Exit from the sketch, and here go for shaft. Okay, select the vertical plane, this axis. Okay, so you need to select this axis. You have a sketch, so I have selected the sketch. Okay, now this completes the Tommy bar. We have a fillet little bit here. It's okay, no problem. Go for next part. It is washer. P, select this part. Okay, enter as washer. Okay, and select the same vertical plane. Go for sketch. Here you need to draw this profile. Here draw the profile in this manner, and go for constraint. This side is of 5.5. It is mentioned here, and entire length is of 8 mm. Height, that means height. So this I should shift it up, and this is of 90 degree. I go for 90 degree, that becomes 45 on one direction. Make it as 45, and here from this point, from this line to this axis, it is inside hole. It is mentioned here is 12 diameter. Go for 6, and the height, so outer diameter is 35. Go for 35 divided by 2. 35 divided by 2. And what else remaining is, so this is 45. Let me drag it inside here like this, and I'll give angle 45. So this is given as 45 already. The height is of it is all constraint. Okay, exit from the workbench, go for shaft, select the direction. If not, click here, right click, select Z axis. Okay, so this will be your washer like this. Then it is done all. So we need to call for assembly. Here go for start. Before that you need to save all the parts. So save, it is in screw jack assembly. Save. Okay, save this Tommy bar and screw and cup. All you need to save. I didn't save before. After completing, you need to save all this. Okay, save. Okay. Okay, done. That's it. I have saved this. So let us save again. Save as a body. And we go for assembly, mechanical design, assembly, design. Here we should click on this existing component and click on this product. Here you should select okay, click on this assembly, open, select all up to here. This is an extra part. Open all the parts we have selected. So you will get all the parts here like this. Now you need to start assembling by selecting this. I'll show you the constraints. Here it is coincide constraint. Click on this, select this and this. Before that you should select these two nuts. Okay, now click on this, select this and this, Control U. Okay, now drag this above. So select a manipulation on the direction of Z. Select this, the Z direction you can push up. Now coincide constraint. Click this face of top, body of top and bottom of this nut. Here again Control U for update. Again in the same way, select this face and the below face of this spindle. Again click on this update. Okay, then we need to attach let me push this above and here